QuadQuiz!
Brought to you by Math with Sir Lester. There are 3 questions for this video, and you are to answer them in 15 seconds each. Are you ready? In 3, 2, 1. Let's have 3 questions for this function. The first one. What is the vertex of the graph of the given function? We can see the vertex of the graph at 2, 8. Second question. What is the axis or the line of symmetry of the graph of the given function? The line of symmetry is at x equals 2. And the third question, how many x-intercepts are there in the graph of the given function, and what are they? The correct answer, we have 2 intercepts at 0, 0 and 4, 0. Did you get 3 over 3? If not, please continue viewing this video. Let's discuss here how do we solve the vertex, its connection to the axis or line of symmetry, and the idea of solving the intercepts of this given quadratic function. Now let's start with the vertex. The vertex is a point on the graph of this quadratic function where the graph changes its direction. We can use here the same a, b, and c coefficients of equivalent quadratic equation. So a coefficient is the coefficient of x squared, which is -2. B is 8, the coefficient of x. And since we don't have any constant here, c is 0. Now, with these coefficients, we can determine the vertex. Okay? The vertex, one of the ways, by the way, in solving for the vertex is that the vertex is a point on our Cartesian plane. Hence, it's a combination of x and y coordinates. The x coordinate of a vertex is -b over 2a. Okay, so we plug in here the b and a coefficients, we'll get the x coordinate of our vertex. For our y coordinate, it's 4ac minus b squared over 4a. Now, we can plug in here a, b, and c coefficients to get our y, but of course, there's also one thing that will let us not memorize this anymore. For the simple concept of this, once you will get your x coordinate of your vertex, just like any other point in our Cartesian plane, use that value of x, substitute that in our function, the result should be the paired y coordinate. And that is how we do it in solving for the vertex here. So let's start with the x coordinate. X is again -b over 2a. So our b is 8, so we have -8 over 2 times our a, which is -2. So you will have here -8 over -4. With this, the x coordinate of our vertex is positive 2. So let's now substitute that in our given function. Take note again, in the context of Cartesian plane, f of x stands for the y. That is why once we solve for value of x, or once we use a certain value of x, such as here f of 2, the result for the function would be equivalent to y. So you have -2 times 2 squared plus 8 times 2. So here, by exponentiation first, -2 times 4 plus 16. That's -8 plus 16. So our result for f of 2 is positive 8. And this is actually the value of y. In short, our vertex, which is also known as the point of inflection or where the graph changes its direction, is at 2 and 8. Okay? So this is the vertex of this given function. Now, we are not required to draw a graph here, but let me just try to draw a graph for illustration of the next idea, the line of symmetry or the axis of symmetry. Let's have 1 and 2. Okay, we have here 2, 1, 2, 3, 4, 5, 6, 7, and 8. Okay. Our vertex is at 2 and 8, and it should be here. Of course, this is our x-axis, this is our y, or we can also label this as our f of x. Now, if we are to graph, just for illustration, notice that our a coefficient here is negative. In our previous videos discussions, if our a coefficient is negative, our graph should open downward. Okay? Again, the graph should open downward. So just like this. I'm just trying to assume that my graph is correct. Okay? So we have here this graph, or let me make it better. Okay, probably like this one here and this one here. Okay? So it opens downward because our a coefficient is a negative integer. Again, you might want to review the idea of that in the previous videos. Okay. The axis or the line of symmetry is, which is our second concern, okay, is a vertical line. Okay, is an imaginary vertical line that divides this parabolic graph into mirror images. So it's something like this here. This is the axis of symmetry or the line of symmetry, because if my graph is accurate, it divides the graph into mirror images. So our goal here is to find what is the value of this line. Now, in our Math 8 concept, if our line is a vertical line, it has an equivalent equation of x equal to something. And that something is the value of x that intersects with our vertical line, or in this case, axis of symmetry, this point here. This point here corresponds to the x value of your vertex, which is this one here. So, just for the illustration of the graph, our axis of symmetry intersects at 2. Even without this graph, okay, let's just erase this graph in our mind, we can still determine the axis of symmetry by just focusing on the x value of your vertex. So the axis of symmetry, also known as the line of symmetry, is at x equal to 2. So again, automatically, once you're done with this portion here, even without the other pair, once you get the value of x, that is automatically your axis or line of symmetry. This is why the axis or line of symmetry is connected to your vertex. So without even this graph, you can determine the axis or line of symmetry. Now for the third one, this may no longer be connected to the vertex, but it has a direct relationship with our graph. Again, we are not tasked to draw a graph here, but for illustration, let me just describe what intercepts are, specifically x-intercepts. These are points on our x-axis, because it's called x-intercepts, point on our x-axis where our graph intersects. As you can see, our graph is opening downward, and this goes without bound. Sooner or later, there would be portions on our x-axis where this graph will intersect, and those are your x-intercepts. Without solving for anything, just by looking at your graph, you can already say that there are two x-intercepts, because then again, there are 2 points where this parabolic graph will intersect together with the x-axis. But of course, we are not just concerned with how many intercepts are there. And at the same time, we may not need a graph for the next few processes. We can still determine the number of intercepts. The x-intercepts are related to the number of the roots of your quadratic function. So here, we are just going to solve for the roots first, okay? So looking back at our given function, you have negative 2x squared plus 8x. Let us equate this to 0 to get or to solve for the roots. Now let's check if we really have two x-intercepts, to which we already verified during the graph. But if you're going to remove this graph in our mind, we can still determine the number of x-intercepts by the number of roots here. This, if you're going to review your roots of quadratic equation, we have here an incomplete quadratic equation since we don't have the c coefficient. And in that case, we can use the common monomial factoring. We factor out -2. Why -2? Because so that our pair here will just be x. Okay, we take out -2 because once you return by multiplication, you will get -2x squared. Once you take out negative from positive, it's still negative here, and you'll have -4. Of course, you could always check by distributive property. -2x times x, -2x squared. -2 times -4 is +8, and you have your x. Now, this is by common monomial factor. This is only possible if you don't have c coefficient. Now, according to this, according to the zero factor, zero product property, this equation could only be true if one or both of them, both of the factors are equal to 0. So we equate both of the factors here to 0. So -2x squared, 2x is equal to 0. X minus 4 is also equal to 0. And solve for the value of x. When you divide both sides by -2, this is still 0. Here, when you add both sides by 4, you will have +4. As you can see, we have two roots. This corresponds to the number of intercepts by analyzing the graph. But if we don't have the graph, you can count on this and then determine the number of x-intercepts. Aside from that, even without the graph, we can further identify what are the x-intercepts. We are not just looking at how many x-intercepts are there, but we are also looking at what are the intercepts. The intercepts, just like the vertex, is a point on our Cartesian plane, right? This one and this one here. So they are a combination of x and y coordinates. If we're talking about x-intercepts, they are a point on our Cartesian plane, or specifically on the x-axis. That's why the y coordinates are always 0. And you will have your roots here, x, and your 4, which is here. So basically, your graph should pass to the origin and 4, 0 here, so that your graph would be accurate. So these are the intercepts, 0, 0, and 4, 0, using the concept of roots of the quadratic function. These are all the discussions to the answer to this QuadQuiz. Subscribe now.